my name is Taylor Bradbury. I am the Gifted and Talented Coordinator at Harmony. So I'm going to be in charge of the science fair today, and it's our very first virtual science fair, and we are so excited to have you. So our science fair participants this year are a bunch of awesome 3rd and 4th grade students. We cannot wait to see your projects. Okay, so our science fair. So here's the agenda for today. We're going to do a judge's introduction. So the judges are going to introduce themselves and let you know who they are, what they do, and what science means to them. Then we're going to have student presentations, and the students will be able to share their project for 1 minute. I have a copy of all the documents that you've sent me. So if you would like me to share your project board document, I would be happy to do that. Then the judges, after all student presentations, so the students will present for 1 minute. Afterwards, one of our 3 judges will ask you a follow-up question just to get a little more information about your project. After all students have presented, then the judges will go to a breakout room. We have already sent the projects to the judges, so they've already made their remarks, but we're going to take a quick breakout session just to discuss who we think should move on to regional fair. And then finally, we will announce the winners that are going to move on to the Austin Energy Regional Science Fair. But there is also an announcement after that, so please make sure you stay till the end of the event. So the judge's introduction, I'm going to go ahead and let Eric go first. If you would just like to say your name and what you do and maybe why science is important to you.
All right, hello, my name is Eric Cieslinski. I'm a teacher, actually, a middle school science teacher, 7th grade. And I'm over at Canyon Ridge over in Steiner Ranch area. And I actually had Miss Bradbury be my judge for my science fair that we also had today. So yeah, I'm glad to be here. Glad to see in the eyes of a 3rd, 4th, 5th grade science fair, and I'm looking forward to hearing about your projects, guys.
Awesome, thank you, Eric. Josie, would you like to go next?
Hi everyone, I'm Josie. I'm a data scientist at Deloitte, and science is important to me because it really teaches you how to question everything. So each of y'all had a question that really initiated all these great projects that y'all did. And it's this great opportunity for you to not only learn about the things that you love and the things that are important to you, but also allows you to be capable of creating some really great ideas and eventually great products and great pieces of technology.
Thank you, Josie. Howard, would you like to go ahead and share?
Yes, I am Howard. I do a lot of things. But I love science because science allows us to learn about the present so we can look into the future. How do we help each other? How do we help common man, and to learn about the world around us?
Awesome. Thank you so much. And welcome, judges. Thank you for being here. We are now going to move on to our student presentations. I'd like you guys to take a minute to gather any necessary materials for your presentation. A lot of you had created physical models or things that you needed for your experiment. If you have that with you, we would love for you to show that to us during your presentation. All right, so our first participant that will be presenting their project is Jimmy Tristan in 4th grade. Tristan, if you would like to go ahead and unmute, I'm going to set the timer for 1 minute. So how about you start with the problem, or what was the question that you were trying to figure out?
How to levitate a pencil and make it float.
Okay, so what was your hypothesis?
My hypothesis was I wanted to make a pencil float through levitation. I will be creating a frame to hold the magnets to attract magnets that repel and attract off one another to make the pencil float. So my background information is magnets have been around since before humans, a long time. magnetite attacks metal with iron, nickel, cobalt, certain steels, and other alloys. Magnets can repel off each other. Here.
Tell me how you moved around the pencil. What was the purpose from that? You said that you moved it around just to make it work. Could you tell me a little bit more about why do you think that you had to move around the pencil and to like place it just in the right spot? Why do you think that was?
Well, because like if you put it in the wrong spot, it wouldn't really float that much. Like it wouldn't like just go up into the air. You need to place it in the right spot so it can float.
Okay. Do you know why? Like, why did it have to be in the right spot? Yeah, like if it was in the wrong spot, what do you think happened?
Like it wouldn't float.
Okay. All right. Well, I'm curious of why it wouldn't float then. Maybe we have to do further testing. That's what science is all about, right? If we're not sure why, we got to keep going.
All right. Thank you so much, Tristan. Everyone do a silent cheer for Tristan.
Oh.
Great job, Tristan. That was fantastic. You did a great job presenting. Let's see who's next on the list. The next person who is sharing will be Hailee Hutchinson in 3rd grade. Hailee, you are up. So I'm going to go ahead and share your project. All right. So Hailey's document is a PDF. So I'm trying to figure out how to zoom, but it's looking like this is what we got.
I will hear you.
Hailee, would you like to go ahead and tell us what your project was about?
Yes. So my project was about what effect will different chemicals have on an eggshell.
Great. And what was your hypothesis? What did you think?
My hypothesis was that when an egg is exposed to an acid, it expects the eggshell to dissolve in about 4 days.
And after you did your experiment, what did you figure out, Hailee?
So what I figured out was that vinegar had the most impact on it. Like if vinegar fully dissolved the shell, but all the others they have this sticky white goo stuff. Like this weird white stuff. This weird white stuff.
Oh yeah, no, yeah, we always do.
And
We always do this stuff.
I feel like that was kind of like the eggshell dissolving, so they kind of all had kind of a thing added to them.
Don't bring it out here.
But other than that, the vinegar had the most impact.
Awesome. Well, thank you, Hailee, for sharing that. Josie, you are our judge who is going to ask a follow-up question for Hailee. So Hailee, I'm going to go ahead and put you on mute, or if you could mute yourself. And then Josie's going to ask you a follow-up question about your project. Go ahead, Josie.
All right. Hi, Hailee. Thank you so much for sharing your project with us. So I am dying to know, did you leave your eggs in longer than the 4 days just to see what would happen?
Yes, but I went to my dad's house before those 4 days, so my mom kind of kept track of them. So yes.
We haven't checked in on it.
Nice. Did she see the pickle juice start to break down the eggshell in the same way the vinegar did?
My mom says that it started to, so yeah.
I'm afraid to check it.
Nice. Thank you so much, Hailee.
All right. Thank you so much, Hailee, for your presentation. Everyone, let's give Hailee a silent cheer. Thank you so much, Hailee. All right, we're moving on to the next project. And our next presenter will be Dhev Johnson in 3rd grade. So I'm going to go ahead and pull up your project, Dhev. Awesome. Okay, Dhev, go ahead.
So my idea was, how can water from high ground, the grass represents the ground, like the ground, get underground without big holes in the ground? or big holes going down into the ground. So
That's great, Dhev. What was your hypothesis?
my hypothesis was many small holes in the ground. Wait. My hypothesis was that a lot of small holes would make more caves than big holes, and I'll get to that in just a second. I wanted to find how if a bunch of small holes or very little big holes will make caves faster.
That's great. So what were the results of your experiment, Dhev? I like your models. I see you have the models there.
Okay, so the water would drain down into the dirt, and then it would go to the chalk that we represent as limestone. And limestone will will disintegrate. The water will disintegrate the limestone, and then the excess water will go down into another layer of dirt, then rocks. And if it goes even more, it will reach the bottom where it's collecting water. And the one on the left is the small holes, and the one on the right is the big holes. And
Okay.
Keep going.
No, you can go ahead, Dhev. I was just going to say, what was the conclusion from your experiment?
My conclusion was the small holes took longer, but they made better caves. And also some of the crushed up chalk, the water in the small holes, it made loose soil, so the crushed chalk could get into like little veins. And then it would just like make little veins of chalk, and then it left a bunch of caves. And then with the big holes, it made two big caves, one here and one here. But most of the rest just fell into the dirt. And it didn't make as big as they didn't make as big of veins of the chalk.
All right. Well, thank you so much, Dhev, for sharing that project. Howard is your judge who has a follow-up question for you. Howard?
Hey, Dhev. What is one issue that you ran into, a challenge that you had while doing your experiment?
How we would make the model.
How did you overcome it?
We had to use things from near our house, so we decided not to make it too complicated and just make a simple thing.
Good job, bud.
All right. Thank you so much, Dhev. Silent cheer for Dhev, everybody. That was awesome, Dhev. All right. We're going to move on to our next participant. And that will be Damian Perry in 3rd grade. Damian, I'm going to pull up your project here really quick. All right, Damian, go ahead.
So my project was basically growing crystals. So the crystals took 14 days, so basically 2 weeks, because it said that it was supposed to only take 6 days to grow, but we started on the 3rd day and it took 14 days to do it. Yeah, and we used crystal powder, right? Crystal powder, and we used And there's other places you can find crystals. You can find them in the desert in Mexico, the biggest crystals. And there's all sorts of kind of crystals, a ruby, a diamond.
Well, great. Great. Thank you, Damian. Can you share with us the results of your experiment and the conclusion?
The results was it came out. I just came from, one day I came from camp, and then I went to my room and the crystals, I saw them, they crystallized. So, and then that's it.
All right. Thank you, Damian. So Eric is our judge partnered with you. He has a follow-up question for you to answer. Go ahead, Eric.
Sure. First of all, this is a great idea. It sounded like from your presentation, you learned a lot about crystals, and not just the crystals that you were working with, but all different kinds of crystals. So good job on your research, man. It sounds like you really know what you're talking about. Okay.
Thank you.
What do you think will happen with the sugars and salt? I see that your data chart has the growth for zeros across the board. What are your thoughts on how sugar and salt, how do they come about? Do you think that they just grow in a matter of a month or a year? Did you get to look into that? What do you think?
I did this at a camp, but it didn't come out right, and it usually took like 4 weeks, a month. It took a month to do.
So this really interests you then, huh?
Yeah.
Because you did it twice, and that's great, man.
And the reason I really wanted to do this so I could have crystal candy.
I love crystal candy, dude. That's great. Thank you so much, man.
Thank you.
Thank you, Damian. I love how you related your experiment to real life there. I think we could all enjoy some crystal candy. Thank you, Damian. All right, let me go ahead and see who is next on our list. We have Charlotte in 3rd grade. Okay, Charlotte, you're up. Go ahead, sweetie. Tell us about your project.
Okay, so where should I? Okay, so my project was how bread rises. And my testable question was, what I asked myself at the beginning was, what makes bread rise better, baking soda or yeast? My hypothesis was they will both rise. Baking soda creates carbon dioxide, and the yeast should also rise. I think that yeast will rise better. And the materials were an old secret family recipe for the yeast bread and cupcake mix for with baking soda. We had some technical difficulties with the results, but they would have said that that the yeast rose less and the baking soda rose much more. And in conclusion, the baking soda rose better, and you can see that based on the chart, and the yeast grew less. My hypothesis was incorrect because the yeast grew less and the baking soda grew much more. In the real world, if you want bigger bread, you should use baking soda.
All right, Charlotte, thank you so much. You were very well spoken. Josie is going to ask you a follow-up question about your project.
Thank you for sharing your project, Charlotte. I wanted to ask you why you chose this topic. What about this topic is important to you?
This topic is important to me because I like baking and I also really enjoy eating sweets and snacks.
Me too, Charlotte. Thank you so much.
Awesome. Silent cheer for Charlotte. Yes. You did such a great job presenting. All right. Let's see who is next on our list. We have 2 more today. Next up is Jackson, 3rd grade. I'm going to go ahead and find your project, Jackson. All right, Jackson, you're up.
So here's my project. Hold on, the train just fell off. Okay, here's my. Hold on. Okay, here's my train. Tilt it. Here's my train, and it barely works. Look, it gets stuck right there. But it works right here. See, it slides. And my hypothesis was I think it can hold quite a bit of weight because magnets are strong. The more weight that gets put on the train, the lower the train will sink. I think the train will touch the magnet track in 60 pennies or with weight of 150 grams.
Jackson, can you share really quick, what was the question that you were trying to ask and to solve?
How much weight can you add to the model mag train before the train touches the track?
Okay, great. So tell us a little more about your results and the conclusion of your experiment.
That one? Mm-hmm. I had planned on only using pennies, but the train could hold more weight than I thought, so we also used nickels and quarters. I found the weight of the different coins. 1 penny equals 2.5 grams, 1 nickel equals 5 grams, 1 quarter equals 5.67 grams. The total weight on the train when there was no visible graphs to the magnets was 455 .19 grams. My hypothesis was incorrect. Mag trains can carry more weight than I thought. These trains are used for passengers, but maybe in the future they could also be used for transporting goods. Maglev trains last longer because of less wear on the train and tracks and cleaner for the environment.
Well, that's great, Jackson. Thank you so much for presenting. Howard is going to ask you a follow-up question about your project.
Hey, Jackson. Based on your experiment, do you think that there's a real-world application for this?
Yes.
How?
Transporting goods like food and materials like metals, because
Awesome.
they could carry a lot of weight.
Nice job. Thank you.
All right. Thank you so much, Jackson. I'm trying to, there we go. Silent cheer for Jackson, everybody. One thing, Jackson, I would like to commend you on. I think that sometimes it's hard to admit that our hypothesis is incorrect. And you did that, and you did it proudly. And I love that, Jackson, because science doesn't always go the way that we thought it was going to. Thank you so much. All right. Last person is Emma, 3rd grade. All right. I'm going to pull up your project, Emma.
So my project is neon crystals, and how we did it is that first we boiled like a powder, and then we like put it, like we put
we like dissolved like the powder, and then we put it in a cup with a string, and one of them wouldn't go down, so we had to put something to make it go down, and then one went in an ice bag. Another one went nowhere cold. It went on the table, and the last one went in the refrigerator. And the results were that the one that was outside got the biggest.
All right, great job presenting, Emma. Eric is going to ask you a follow-up question about your project. Go ahead, Eric.
First of all, this is a great PDF. I was just thinking about cotton candy the entire time. Then I see that rock candy, and I know we were just talking about rock candy, but okay. Well, I'm getting too sidetracked. My question for you, because I noticed in the pictures, and those are great pictures, because I know some people, when they take pictures of their crystals, sometimes they're far away, sometimes they're zoomed in, but I think you really did a really good job of capturing the size of the crystal so that I could see it, and then I could look down at the graph and I could see, oh, that one is longer than the other one, according to your data, which you did a great job. My question for you is about those pictures. Do you think, so I know that you measured the length from what I remember about your crystals. Do you think there's another way that you could measure crystals to maybe find out other questions that you might have about the growth of crystals?
Maybe.
How else do you think that you could measure those crystals?
By touching them, like you can see like how hot they are.
Oh yeah, you can measure the temperature of them. Sure. How about, have you thought about measuring the weight of them?
Kinda.
Yeah, that could be other ways. So, maybe if you were to do this again, because as we all know, science isn't a perfect way of doing things. You just have to keep trying new things. And as more questions come about, we're going to have to test and retest. And it looks like you did a very great job for measuring the length. And it looks like you controlled everything perfectly. And you measured the temperature really, really well. I really do like this project. Thank you so much.
And before I knew, the one that had to be pulled down got like an upside down T crystal.
Oh, that's
because
cool.
it went that like the string. We had to hold it with something.
That's great. That is really cool. Thank you.
All right, everybody, silent cheer for Emma. Great job presenting. Thank you so much for sharing your projects. The judges are now going to be placed into a breakout session for us to discuss which projects we think are going to move on to the Austin Energy Regional Science Festival. Now, I'm going to give you a little information. The Austin Energy Regional Science Festival is where schools from all around the Austin area have students participate and bring their projects, and they get judged by the Austin Energy Regional Science Festival judges. I believe when it was in person, there were over 3,000 participants. I'm not sure if, because it will be virtual this year, if that would affect the numbers, but either way, your projects have the chance to compete for either third place, second place, or first place against tons of students your age in the greater Austin area. So it's a really exciting opportunity. That being said, I also would really love to encourage the students, no matter what happens, if we choose your project or if we just happen to not choose your project this time, that you guys give yourself a huge pat on the back, because you guys all took your personal time outside of school to learn about science and to do awesome, amazing science fair experiments and projects. So really, no matter what happens, if your project gets chosen or not, I would love for all of you guys to just be proud of yourselves and celebrate yourself for all the hard work that you've done. So thank you so much. That being said, I'm going to go ahead and create the breakout rooms for the judges. Went ahead and opened the breakout room for the judges. I'm going to go join them as well. Miss Montenegro is going to take over if you have any questions while we move to the judging breakout room. We're going to come back in 5 minutes, everyone. If you need to use the restroom, let's be back in 5 minutes.
Feel free to turn your cameras off if you'd like, and in 5 minutes, we'll announce when they return. Stay close by.
Thank you, Miss Montenegro. That was amazing. I appreciate you. All right. So the judges have collaborated, and again, keep in mind, if you were not chosen to move on to the regional fair, that's okay. You guys all did such an amazing job, and it really was not an easy choice to decide whose projects were going to move on to regionals. Also keep in mind, if your project is chosen to move on to regionals, you're not going to need to do anything else. We're going to take the project that you already turned in and submit it to the regional fair. The regional fair is virtual this year, and so I'll just kind of be the one to manage that and then give you the information as we go. If your project is chosen to move on to regionals, you can expect to be receiving an email from me tomorrow giving you more information on what to do next. All right, everyone. So remember, I'm going to announce the winners, and then afterwards, I need everyone to stay because I do have one last thing that I need to say. So everyone needs to stay through to the end of the meeting. All right. Our first winner that is going to be moving on to regionals is Dhev Johnson in 3rd grade. Silent cheer for Dhev, everybody. Congratulations. Awesome job, Dhev. All right. And the next project that is moving on to regionals is Hailee Hutchinson in 3rd grade. Hailee Hutchinson, silent cheer, everybody. All right, and I'm gonna make one last announcement for the winner. We have one more. We're gonna take 3 projects. Remember, again, if your project wasn't chosen, please still give yourself a pat on the back and please still celebrate. I do have one more announcement after this as well. The last project we are choosing to move on to regionals is Emma, 3rd grade. Silent cheer for Emma, everybody. All right. Thank you so much to all of the students who participated. We started out with over 100 students saying they're interested, and you 8 students were the ones that followed through. You did the work and you participated, and we really appreciate that. So silent cheer for all of our science fair participants, everyone. Let's make this the biggest one that we can possibly do. Biggest cheer ever. All right, and then I did want to let you guys know that because you guys did such great work, everyone will be receiving a science fair medal coming to you in the mail, along with the certificate of achievement for all of your work that you guys did at this science fair. So each of you is going to be receiving a medal, and I'll be sending that to you. So look out in your mail. You're going to be receiving a certificate and a medal for all of your hard work. All right. Thank you so much, everyone. That's all we had for today. And I really appreciate all of your hard work, you guys. Have a great rest of your night. And
Before you go, I'm sorry, Ms. Bradbury, I believe Ms. Gorman wanted to say a few words.
Okay, go ahead, Ms. Gorman.
Well, thank you so much. I just want to say, first of all, thank you, Ms. Bradbury, for organizing all of this. This has been absolutely fantastic. And I want to say thank you to our parents for all of your support, for all of our students, our teachers for supporting our students and being here, and our incredible scholars. Oh my goodness, y'all inspired me today. Seriously, I am just excited to go and do my own experiments. And this is just the beginning of exploring the world around you and learning. So congratulations to everyone. I'm so incredibly proud of you today. Great job, guys.
Thank you so much, Ms. Gorman. And thank you, everyone. Thank you for coming. Great to see you all.